Welcome everybody to the Sparks Global webinar series. It's great to have you all join us today. Today we're looking at Enterprise Architect 15.2. We're going to be taking a deep dive into math solvers and SysFIS simulation. So my name's Scott Hebbard. I'm the Communications Manager here at Spark Systems, and I'm joined today by Stephen Hall, who's a Senior Software Engineer at Spark Systems with expertise in simulation. So looking forward to our presentation today. The agenda, first we're just going to talk about how to submit questions. Then I'm going to hand over to Stephen Hall, who's going to conduct the Spark Systems simulation discussion and presentation. He's going to work through some examples in the model and show you how it all works. We'll finish up the session with some Q&A and we'll answer your questions. Please note that audio is muted for all participants. So if you have any questions, you'll be able to type those questions to the host. They'll come through to myself. And if we can't get through all the questions live, we'll follow up offline. And typically we publish the video on the Spark Systems YouTube site and on the Spark Systems website. And we try to get the YouTube video up fairly quickly. And we put the Q&A up generally a week after the event. So on screen, you'll see the go to question box. Simply enter the text and hit send, or hit enter on the numeric keypad, and that'll come through to myself. But right now, I'd like to hand over to Stephen Hall, and Stephen is going to present on math solvers and SysFIS simulation. So welcome, Stephen, and I'll hand over to you. I can see your screen and it looks great.
Thanks, Scott. Hello, everyone. My name's Stephen Hall, and today I'll be giving an introductory overview of two of the new maths and simulation features available in the latest Enterprise Architect 15.2. The first new feature is the ability to call and run MATLAB functions directly from Enterprise Architect from anywhere that JavaScript can be run using the new Solver class. You can also call and run Octave functions, which is an open source alternative to MATLAB, but we'll focus on MATLAB today. The second new feature is the new OMG standard for SysFIS to construct SysML models for simulation in third-party programs such as MATLAB Simulink. SysFIS stands for SysML Physical Interaction and Signal Flow Simulation, and it standardizes a common way to specify variables and constants, types, and inputs and outputs for use in third-party simulations. It currently includes support for both the Modelica standard and for MATLAB Simulink. So let's start with using the new solver classes in JavaScript. JavaScript can be used in many places inside Enterprise Architect, including state machine simulations, activity diagrams, BPMN simulations, custom plugins, or as raw scripts to be run on command. To call a MATLAB or Octave function, we have a new class called a solver. You can instantiate a solver class at the start of a script or in the initialization of a state machine or other simulation. The solver can then be used throughout the script or simulation to call MATLAB functions or to get or set variables in the MATLAB workspace. Here we see an example of a plain script invoking a new MATLAB solver and calling a native function. The output of the function is stored in the MATLAB workspace and can be pulled back into JavaScript with a call to the solver to get the variable. As well as running complex maths functions to return the answer to JavaScript and Enterprise Architect, you can also tell MATLAB to run a chart, pop up a custom dialog, or run custom functions and routines. Any command that can be run from MATLAB's internal command line can be run via the solver class. Variables can be passed either as simple types, such as integers or floating point numbers, or character strings or arrays. They'll be automatically converted into the appropriate MATLAB types when set and converted back to the corresponding JavaScript type when retrieved back from MATLAB. Here we see the output of a random number distribution in a MATLAB figure. Here we see an example of an activity diagram that uses MATLAB to generate a complex output plot during different stages of the activity. The solver is created in the first step and can be used in subsequent steps of the activity. When the simulation is run, we see in the output that Enterprise Architect has launched MATLAB in the background and will run through the commands in each action and show the resulting MATLAB generated plot as the final stage. This second example shows the solver being used in a state machine that generates an estimate of the amount of power a solar panel can generate throughout the year. The maths for this equation is complex and relies on the latitude and longitude of where the panel is located. You can see that the solver code is used in a few different places throughout the state machine. The initialization is performed as an effect on the first transition. And more calculations are performed in a transition here. If we look at the code for the plot the day state, we see a larger section of JavaScript for setting up a nice plot for the solar panel power during a 24-hour period. While running the state machine simulation, you are not able to directly view the MATLAB internal workspace variables, but any that have been pulled in with the get command are visible in the local variables tab or can be outputted to the log window. As shown here. All the features of the MATLAB Solver class are available for use with Octave as well, which has an almost identical feature set. The features we use were introduced to MATLAB in the 2017B release and have been fully tested with the 2019 and 2020 releases. Next, we'll move on to looking at the new SysFIS standard from OMG and how it can help visualize and model your simulations. As I said earlier, SysFIS stands for SysML Physical Interaction and Signal Flow Simulation. This means that it's an extension to SysML and as such can be used in SysML models in Enterprise Architect. There are two main types of systems that can be modeled with SysFIS. The first is signal flow, in which an element can send a signal or message to another element. That element can then manipulate the message and combine it with other signals and then pass on a new signal to the next block in the model. This is a more abstract style of modeling and matches up with the core Simulink features. The second type of system that can be modeled is a physical system, in which elements represent real-world objects and connections between them represent real-world physical flow of a substance or energy. We will look at an example of this where the elements are physical tanks to hold water and the equations define how the water will flow from one tank to the other based on variables such as pressure, height of the water, temperature, and viscosity. Previous versions of Enterprise Architect had some of the features of SysFIS available for use with the Modelica simulation library. The new version improves on that base by adding support for simulating using MATLAB Simulink application and allowing more detail about variables and ports to be seen on the diagram itself, allowing the model to self-describe its interactions rather than having to configure them in special simulation windows. For example, variables can be set to either constant or variable by setting a new SysFIS stereotype, and this will show up on the element under a new set of compartments. The initial value of the variable can be set in the properties page and seen on the diagram as well. You can also define and see the type of the variable and the units it's measured in. Before we get started on these examples, it's necessary to import the SysFIS pattern libraries into your model. This defines some base types needed for signal flow and some base physical unit types for physical simulation. Let's look at an example of a SysFIS model using signal flow and how it can be modeled in Enterprise Architect and simulated in Simulink. Here we see an electronic signal processor composed of various filters and amplifiers. The block definition diagram, or BDD, shows that the electronic components are all derived from a base 2-pin component that has an input signal and an output signal. The ports are typed using the new SysFIS types that we just imported and are named as per the SysFIS specification. If we look at the high-pass filter, we see it has one SysFIS variable and one constant, giving a consistent visual indication of the variable types. We can see the variable is using the new stereotype PHS variable. If we drill down into the internals of the high-pass filter, we see a parametric diagram detailing the equations that govern the filter. For signal flow models, the equations have a single output on the left-hand side or a single derivative of an internal variable. Looking at the main signal processor block now, if we look at its internal structure, we see an internal block definition diagram, or IBD, that shows the flow of signals between instances of the various blocks. The signal processor itself has an input and output, allowing it to be connected to and used in larger models. The signal flows from the input through an amplifier, then it's split into both the low pass and high pass filter, and then signals are mixed back together and sent to the output. We see the initial values of the internal variables on the properties themselves, which would allow easy differentiation if, say, you had multiple high-pass filters with different values on the same diagram. The signal processor itself is connected up to a source and a scope viewer to allow the simulation to be performed. To run the simulation, use the SysML sim configuration artifact. Generate and run the simulation by clicking Solve. While we wait for MATLAB and Simulink to start in the background, you'll see we can now choose either Simulink or Modelica from the drop-down here. We see all our blocks defined on the left and a list of output properties on the right that can be plotted in Simulink. When finished, this will open MATLAB Simulink and show the output of the selected variables. Here's Simulink's graph of the output. To quickly see the effect of changing initial conditions, you can create a new data set in the simulation configuration screen. Here we have defined new initial values for the amplifier to provide more initial amplification to the signal. Running the simulation again shows the larger signal. You compare the diagrams here. Next, we'll look at a physical interaction model. This represents the physical flow of water from one tank to another via a pipe. To run this in Simulink, you need the SimScape extension that allows for physical modeling of systems. The difference with SimScape is that a connection between two blocks represents a physical connection between the components and allows for bidirectional flow of a substance or energy between the two components based on balancing the equations of each block. Here we see our block definition diagram showing the blocks for the tank, reservoir, and a connecting pipe. We see some variables and constants as well as some default initial values and real-world physical units. The internal structure contains some equations governing how water will flow into or out of the opening based on pressure and other variables. Next, we see the internal block diagram showing how the components are connected together. We see the first tank connecting to a pipe, which connects to a second tank. The initial height of the water in the two tanks is different, which will cause a pressure difference, which will cause the water to flow between the tanks through the pipe until the pressure is equalized. To run the simulation, we again double-click on the simulation artifact and set up the simulation to run in either Open Modelica or Simulink. We'll run this first with the default dataset where the initial values are taken from the properties of the elements themselves. You can see the output of the script running, and any errors or warnings from MATLAB will show up there as well. This is Simulink's output plot, and we see the heights of the water in the two tanks start with tank 1 higher than tank 2. And as the water flows from the more full tank to the other, the height equalizes as the pressure equalizes, settling on a final value. Next, we'll run with a different data set, which will override any default initial values on the elements or blocks and use the values specified here. You can see that if we specify a larger diameter pipe, then the water pressure and heights equalizes much quicker than with the narrower pipe. State machines in Enterprise Architect can be used to control the flow of a SysVis simulation. These state machines can also be exported to Simulink using another extension called Stateflow that adds state machine control to Simulink diagrams. We see in this example a signal flow model of a humidifier system. To simulate user interaction and control the on-off state of the machine, there are a handful of SysML state machines. When we simulate this with Simulink, you can see that the state flow diagrams are created to match what was in Enterprise Architect. Once simulating in Simulink, you are able to debug the state machines and step through them at different speeds while inspecting the variables. These state machines are useful for cases where the equations are nonlinear and depend on the state of the system to pick which equations to use. In this case, the equations for when the humidifier is on versus when it is off are different and mostly independent, so controlling via a state machine makes sense in this situation. Enterprise Architect includes a few patterns that reference common blocks that exist in both Simulink and Modelica. These common blocks are those that are defined by the SysVis standard. You can access them via the patterns icon in the SysVis toolbox. It's also possible to reference other existing blocks, including custom blocks that you've written yourself, by specifying the name of the library block and its inputs and outputs. Here we can see model blocks that reference a resistor, op-amp, and other electrical components to model an inverting op-amp using components that already exist in Simulink. Another thing you may want to do is have a high-level model inside Enterprise Architect, but the detailed mathematical view of the model kept inside Modelica or Simulink. This is possible too. Enterprise Architect will generate the outline of the model in Simulink for you and allow the details to be filled in later in Simulink. Conversely, you may already have detailed blocks well defined inside Simulink, in which case you are able to reference those blocks from within EA to incorporate them into the larger model. Here we see a high-level model of the system within Enterprise Architect. The blocks are defined and the IBD shows how the parts are connected together. But there are no constraint equations governing the block's behavior. After running the simulation, you'll end up with Simulink files that show the block structure and connections, but have no internal structure. Here's the main model and the connections, but then the details of the internal block are undefined still, to be left up to be defined in Simulink later on. Once the outline structure is generated for Simulink, it won't be generated again each time, so changes made inside Simulink will remain. And that concludes this introductory overview of 2 of the new maths and simulation features available in the latest Enterprise Architect 15.2. I'll pass back to Scott to go over any questions posted during the presentation. Thank you.
Thanks, Stephen. That was really great. It was great to see how easy it is to get that integration happening. So what I would like to do is I just want to share a compare editions page, because one of the questions that's come through from Dean was, do you need to download an MDG technology for this to work? And what edition of Enterprise Architect is required to run simulation? So perhaps you could speak about that and maybe the simulation tab in Enterprise Architect, Stephen.
So you don't need to download any new profiles or technologies. The simulation runs off the SysML models. So if you have SysML modeling enabled and are using that, then you can use the existing one there. Scott's just scrolling down the page. I don't know where it is, I think.
So here's Simscape integration. So it's from Unified and above. So what I always encourage customers to do is to have a look at this compare editions page, and you can see then what version of Enterprise Architect you require for given technologies. So usually Ultimate covers everything, but yes, I can see here that a lot of these simulation capabilities are also available in the Unified Edition. So, and you can see here you've got Simlink integration, and Simscape integration is in the Ultimate Edition and the Unified Edition. So, if you get the Unified Edition, you should be well covered.
And of course, you need valid Simscape and Simulink licenses as well.
Absolutely, and I think that's an important point to note. So following up on that, what are some of the advantages of integrating the modeling tools within Enterprise Architect and the capabilities of Enterprise Architect with some of these tools like Simscape and MATLAB?
I think generally the biggest advantage is allows you to keep all your modeling in the one place and not have it spread around in different tools. Use Enterprise Architect to model the entire system, and when you want to simulate, you can just press play. You can set it up to perform that. When you make changes, to check if the simulation still gives the same output, rather than having to go back and forth between different tools. Having a model in Simulink but different model in Enterprise Architect and trying to keep them synchronized would be quite a pain, I suspect. It allows for good auditing of the model and yeah, keeping it all in one place.
Fantastic. If throughout the process of generating some of these graphs, you would like to use them in reports and in documentation, is there any way that you can capture some of these diagrams and include them in reports?
That's a very good question. I haven't actually tried to do that. You are able to run any MATLAB command that exists, which would include saving screenshots or printouts of those graphs and reports to files, which then should be able to be referenced inside Enterprise Architect. There's no automated way to set that up, but if you saved out to known locations from MATLAB, then you'd be able to reference those as well.
Excellent. We've had a question from a couple of customers just about being able to access some of the examples that you've shown today. So if people wanted to see more examples of some of these models, and if people wanted to get hold of some of the solver classes, if they haven't previously written any JavaScript code or written a solver before, where might they be able to get access to some of these examples?
So we have a demonstration model that currently has access via WebEA made publicly available, and we'll post a link to that when the video goes up online. We also will be happy to share the model with anyone that asks for it, and it will probably be made publicly available as well at some point.
Yes, we'll make it available on the webinar page itself, so you can download the model, and yes, we'll provide links to that content.
And that will include all the models I've shown today, as well as a handful more and a few more scripts as well.
Excellent. Well, thanks very much, Stephen. I might just have a look and see if there's one or two more questions. So there's one more question here from Robert that just says, how do you set the path in EA for MATLAB, Simulink, and OpenModelica? So you'd be able to talk about that.
In the majority of cases, it will automatically detect where MATLAB is installed. If you have multiple versions installed, or for whatever reason it doesn't work, on the simulation configuration screen where there's the drop down next to Simulink, there's also a little menu button that allows you to configure the path to the MATLAB binary.
Fantastic. Thank you very much. So we might just wrap up. We have more Enterprise Architect webinars coming up. So please keep an eye out on sparksystems.com/webinars for future titles, and have a look at our webinar library to see hundreds of hours of free webinars that are available. As always, if you have any suggestions for future webinars or topics, please email webinar@sparksystems.com and we'd be happy to respond to them. As both Steve and I have mentioned, a copy of this webinar will be made available on the Spark Systems website, and we'll get a copy up on YouTube as quickly as we can today. It usually just takes half an hour to render, so we'll get that up and posted, and we'll respond to some of your Q&A and get that listed on the Spark Systems website within a week. I'd like to thank you all for your attendance and for your very thoughtful and interesting questions. Thanks very much, Stephen, for your contribution today and for going through the webinar. And
Thanks, Scott.
I look forward to seeing everyone again at future webinars. Thanks for joining us today, and have a wonderful day, morning, afternoon, or evening, depending where you are in the world. So thank you.